Cool. All right. So like Angelica said, we're going to be looking at how to do import and modeling with a data set that we've taken off the internet. So I'll do just a quick introduction to me, just in case you want to get in contact afterwards. You can either do that by email directly to me, or we have a developer relations email, and that will go to me and a few of my colleagues. So with that, this is our plan for the next 45-50 minutes or so. So we're going to have a look at a data set. So I'll explain what that is in a minute. And then most of the session, we're going to spend looking at how we would go about modeling that in a graph. And then we'll look at some different ways that we can import that data. So we'll look at a few tools that are available to you if you're building your Neo4j application. And then we'll finish off with just a couple of queries that we can do on that. But we're not going to spend much time on that. We're focusing mainly on the other two sections. So the data, what data set are we going to look at? So we're going to look at the Yelp Dataset Challenge. So this is a competition that Yelp have been running for probably the last 5 or 6 years. And you can see there's a link to it down the bottom of the screen. So we'll just quickly go out of the view and go over to that. So you can see here, yelp.com/dataset challenge. So this is what the website looks like. And they do a bit of explanation of the data set, and they give you a few ways that you can download it. So you can either get a JSON version or a SQL version. And then if I go over to the second tab over here, you can see what the data looks like. So we get some businesses, we've got some reviews, we've got some users, we've got some check-ins, and we've got some tips, and we've got some photos. So it's hopefully reasonably accessible types of data. So even if you haven't used Yelp, probably those things are still reasonably familiar to you. And we're going to come back to these and look at how we go from these JSON files to a Neo4j structure in just a minute. I'm just going to come back here. Second, we'll just do a quick introduction to the graph data model. So like I said, so this is an overview from that page of what data we're working with. So there are 5 million reviews of 174,000 businesses. People have taken 200,000 pictures. We're going to ignore the pictures for this session, but that could be another area of interest if you're interested in doing image analysis. And they're across 11 metropolitan areas. So they're across several cities in Germany, the UK, and the US. And then there are a bunch of attributes on each of those businesses, which you probably saw on the previous when we looked at the web page. So they include the opening hours, whether they have parking, what availability they have, and the ambiance at each place. Okay, so how do we go from that Yelp set of JSON files to a graph data model? So Neo4j uses what we call the labeled property graph model, and there's a diagram of it on the screen at the moment. So at the center we have nodes, and these are representing the pieces of data in our domain. So they would be, if you're familiar with a relational database, that would be pretty similar to a record in there. Those nodes are then connected together by relationships. So you could consider that a pre-computed index between the nodes. So we can effectively go between those nodes that do have a relationship really quickly. So rather in a SQL query, we might have to calculate that join at query time. In Neo4j, we write that relationship or that join into the database. It's actually stored in there. And then the last bit are the properties. So those are the key value pairs that you see around that can go on nodes and relationships. And those would be used to store attributes or metadata for our nodes or relationships. So for example, in the Yelp dataset, maybe we're going to store it on a business node, we might store a name. So that could be an example. And they can be Java primitive values, or you can store literal arrays. Another way to think about it, if you prefer using the sort of English parts of speech terminology, I'm not the greatest at this, but if you are, then this is another nice way to think about it, is that nodes are often represented by nouns. The properties would be adjectives, and the relationship would be an adverb connecting them together. These ideas, that's a rule of thumb one. There'll certainly be examples where maybe that doesn't quite work, but it's a good starting point. Here, this is an example showing the property graph model with some sample data. So this is what we've got on the screen at the moment, is a very small graph. So we've got two people rather. We've got Dan and Anne at the top, and we've got their car at the bottom. And you can see we've got some relationships going between the two people. So luckily they both love each other, and then they live with each other as well. And we're saying that Dan drives the car, but Anne owns the car. And so that covers all the things. So we've got our nodes, so the Dan and Anne structures and the Volvo structure. The properties are then defining what exactly does that node represent. So in this case, we've got the Anne node has a name and a born property. The Dan one has a name, a born, and a Twitter property. That's one thing to notice that's a bit different from what you might be used to, just because, sorry, the last bit is that we've got labels on there. So you can see we've got a person label on both the people, is that just because both of those nodes have the same label, it doesn't mean that we have to have the same set of properties to go alongside. So you can see Anne doesn't have a Twitter account. In a relational model, we might have to specify that there is a Twitter column and then we just have it null. In this graph model, we just don't specify a property. And then we've got some properties on the relationships as well, indicating when Dan has been driving the car. Okay, so we want to try and make a model like that for our data set. We're going to follow this structure. So we're going to try and work out what are the entities, i.e. what are the main pieces of data that we've got in our data set. We'll then look at what properties are interesting. We need to find a unique identifier for each of our nodes or for each of our entities so that we don't end up creating the same data twice. We'll then look at how the pieces of data can be connected, and then we'll repeat the process as necessary. For this section of the talk, I'm going to show you a tool called arrows, which I've got over here on my fourth tab. So we're going to have arrows on one side of the screen, and we're going to have the Yelp dataset on the other, so we can remember what it is that we're trying to model. So this is, we can share the link with this tool afterwards. This is a tool written by one of my colleagues for allowing you to quickly sketch out graph models. So we'll start at the top. So we've got some businesses, and those seem like an important thing in this domain. So let's start off. So where it says caption, we can fill in the label, and we'll call it a business. And there's a business ID. We don't really need to include business in the name because it's already on a node with that label. But we'll call it ID. I guess the name is probably quite interesting. And then there are some other things as well. Perhaps we want to capture the city. The city seems like a reasonable thing to capture. We could probably also add the state in the postal code as well. We've got categories, so we could add categories in here as a set of strings. We could go like write it in like that. But categories actually seems like something that might be interesting for graph querying. So for example, if we found a business that we like and we wanted to find other similar businesses, it may well be that we want to go through those categories to try and find those similar businesses. So we're gonna park the idea of having categories as an array of strings for now. But we'll just finish creating our business. So you can see here we've got our business node, and we're just indicating what type of data those properties have. Now we're gonna handle the category. So what we want to do is actually we'll create category as another node, and this will allow us to query through it. So we'll create a category node, and they've only got one thing. There's no identifier for categories. So they just have a name. So we'll just put that in. So say cool. I've got my category name. And now we need to work out what should be the connection between these two things. So we just draw, if you hover around the edge of it, we get a little arrow comes up, and we can draw a relationship between them. What we need to do now is name it. And so what you normally try and do is keep it in the present tense and keep it, use an active verb if you can. I think in category works pretty well for this. So we've got, at the moment, our graph would be business is in a category. We can scroll down. There's some other stuff in there, but probably we've captured the main stuff we want. Perhaps you could do something clever around the hours if you wanted to model that sort of stuff. But for now, let's go down and have a look at reviews. So the way reviews work, so you can see we've got a review ID at the top, and then we've got a user ID just below it, and then we've got a business ID. So there's three things involved in this. So the review ID is representing, okay, this is a specific review. The user ID is obviously referring to who wrote the review, and the business ID is indicating what business the review is about. So it kind of indicates we need to have a user, and then the user writes the review about a business. And one way we can model that. So let's put maybe we'll start with the user. So let's go down here. We're going to create a node for our user. So we'll put in a caption user. Again, we've got an ID for the user and we've got a name for the user. And we'll just have that information for now. And the user, one way of doing this could be, we could do it like this. We could say, okay, user wrote a review about the business, and we could capture the text, and we could capture the number of stars that they gave the business. And that would work okay, but it now becomes like, you could imagine that one thing we might want to do is pull out interesting entities or interesting commonly used phrases in our reviews, and then enhance our graph with the sort of NLP type information. And it's not possible to connect other things into a relationship. So actually this model doesn't work very well for what we might want to do. So what I want to do instead is actually have review as a node. So I'm gonna bring that in over here. So let's just check what properties do we have on a review. So we'll put in our caption for our review. We've got an identifier, and we've got our number of stars, and we've got our text. There's other information on here as well that you can see on the left-hand side, but we're not going to put all of it in for this example. So we got our review, and the review reviews a business. So let's connect that together, and we'll just fill that in. So we'll call it reviews. So present tense again, and we're saying that the user wrote the review. Okay, user wrote the review. And now we don't really need this one anymore. So we can just click on it and we'll just put a delete. So we've got a reasonably, this is a good model to start with. So we've got user wrote a review and about a business, and it's in a particular category. There's other stuff that we could do if we wanted. So there's check-in information. There are tips as well. But I think this is pretty good to start with. So what we'll do now is we'll just put this back to the full screen. We'll download SVG of that. And we'll take a print screen of this, and we're going to stick it into our presentation. So we've got our model ready to go. So let's get that. Got a massive arrow there. Let's get rid of that, and we'll just switch back to here, and we can put our little model in the bottom right hand side of our slide deck. So there we go. So we've got a model that we're going to work with. Maybe I can make it a bit bigger. So that's what that's what we want to get towards. So we want user wrote a review, reviewing a business, and the business is in a category. Next thing we need to figure out is how are we going to import data into that model. And we're going to look at three tools for doing this. So we've got APOC, which is the awesome procedures on Cypher library, procedures and functions rather. We've got the Neo4j drivers, so we can put data into our application directly from our programming language of choice. And then we've got the Neo4j import tool, which is very good for doing initial imports of big data sets. So we'll start with APOC. And so what is APOC, I guess, would be the first question. So this is a procedures and functions library that the community has been building since, I think it was about March 2016 or around then. So it's had a couple of years effort so far. A nice way of thinking of this is it is basically the Swiss Army knife of libraries. There is something for everybody. And at the moment, there are more than 400 procedures and functions in here. So there's, beyond just doing data import, you can probably find something in here that will help you with data cleaning or with any other utility or problem that you might find yourself coming across. It's actually now really easy to install. So this is a screenshot of the Neo4j desktop that was released in October 2017. So on the 3.3 release series. And this is the new place for doing all your Neo4j work. And you can I'm gonna demo using this, but just to show you, if you want to install APOC, it's as simple as clicking that install button on the left-hand side of the screen. In previous versions, you would have had to go to GitHub, the GitHub release page, find the appropriate jar for your Neo4j version and put it into the plugins folder. So that's all completely automated for you now. So it's easier than ever to get up and running with this. Now, the first thing we want to do is we want to set up our indexes and schema for the database. So indexes in Neo4j are used to just find the starting points of the query. And those are the first two things we see here. So you can see category name and business name. So we might want to search, you could imagine we might want to go and find the businesses in a certain category, or we might want to go and look up a specific business by name. So we're going to put some indexes on there. And then the second argument given to this procedure is creating what we call unique constraints. And what this does is it says that we can't have any duplicate. So if we go from left to right, we can't have any duplicate nodes which have the business label and an ID property. So there can only be one unique version of that ID property for that business label. And then we're doing the same thing for users and reviews. So we don't want duplicate businesses, users, or reviews. And we want to be able to quickly find what we use indexes to find what we call the starting points of queries. And we'll see some queries where I'll point out later on how exactly that works. So this is a nice procedure that wraps up having to go and execute create index on or create constraint on syntax in Cypher. So this wraps all of it for you. But where we were going to really focus for the next part of the session is on the APOC load JSON function. So this is, in case you haven't seen procedures, this is a procedure. And you can see down the bottom of the screen, I've taken a print screen of the documentation for the APOC library. And this is how you would, this is a simple example of how you would call APOC load JSON. So at the top, we're defining a URL where our JSON file exists. That can either be somewhere on the internet, so it could be a HTTP link, or it can be a file system link. And so we're going to look at file system links in case you notice the discrepancy between the examples. Once we've got that URL, we say call apoc.load.json, we pass it in, and what it gives us back is a parameter called variable name called value, and we can then, in this case, we're just changing that so that we refer to it as person, and it will have a map of all the properties that the JSON file contained. In this case, it's a fairly simple one, so it only has an array of name of people, and they have a name property, an age property, and a children property. And so we're creating a person from that JSON file. For us, we've obviously got different JSON files. So this is how, and what we're going to start with is we're just going to do some exploration of the data. So I've got an example here of how we would query the business JSON file from the Yelp dataset. At this point, I'm going to step out of the presentation. I'm going to come over to the Neo4j desktop. So in case you haven't seen it, what I have on the screen now, this is the Neo4j desktop, and this is where this is what you'll get if you download Neo4j today. And you can see on the left-hand side, you can create yourself projects for whatever application you're working on. So you can see I've got a few different ones for stuff I've been working on, but today we're in my Yelp one that I've got the mouse on now. And I can create lots of different databases in here. So you can see I've got a few versions, and we'll have a look at those later on. And then at the top, I've got the Neo4j browser. And I'm just going to switch over to that. So this is my Neo4j browser instance, and I've got some saved scripts. I've cheated a bit here. So in the browser, when you write a query, you can actually save it with a comment. And I'm going to use one of those. So this on the screen at the moment is a query for exploring the dataset. So if I just run it so you can see how it works. And we'll just go through it. So we're saying I want to call that APOC load JSON function, and I've got a file and it's in this location on my machine. So you can see it's in my projects, Yelp, graph algorithms, dataset, business JSON. And all we're doing here is we're just returning the first 10 businesses in that file. And it comes back. We've got the hours, we've got the address, we've got the city. It's exactly the same as what we saw on the Yelp website, but this time it's obviously filled in with a specific company's information rather than just being an outline. And we can scroll through and we can see what it looks like for a few of the different businesses. And if you wanted to, you could say, okay, I just want to get the name. So I could change this thing, just return the name. And then we just get the names of the top 10 businesses in that file. Those files are, they're not actually like completely valid JSON, so it's streaming JSON. So it's one row has one valid piece of JSON on it, and so APOC load JSON is able to handle that structure for you. So you don't need to do anything any special data cleansing or anything of that sort. What I want to do next, though, is show you how we might create that structure that we looked at before. So on the screen now, we've got the first lines the same as before, and I'm just filtering it so that we just process the first 1,000 businesses. And once we've got them, so we get this gets us this bit here, loads in the first 1,000 records from the business JSON file. We're then calling the merge function. So merge is a Cypher clause, and it will create the business based on this ID. Remember that's if it doesn't exist, and if it does exist, it will just return it. So we'll just have the B will be referring to something that's already in the database. What we're doing on the next line is we're saying I want to then set some properties on that business node that I've just created. And we're cheating a bit here. So we've got a nice function in APOC called apoc.map.clean, and we can tell it which properties we don't want to have. So we're just saying take out attributes, take out hours, take out business ID because we've already got it, take out categories because we're going to create a relationship to that, take out address, take out postal code, but it will keep everything else. So it's quite a nice tool for filtering incoming maps. And then on the next few lines, we're working out how to connect the business to its categories. So the categories are on the categories property on the original JSON, and we're using and they come as an array, and so we're using the unwind function. So this is another Cypher clause, and it takes an array and explodes it out into individual rows, and this is very helpful because we can then connect those to use it to help us connect the categories to the businesses. So I'm just going to run that. Yeah, it should take a few seconds. So you can see it's now created 1,500 nodes, 10,000 properties, 3,000 relationships, and we could go over here and we could click on that and we can see what's been created. So for example, what we've got on the screen at the moment, I'll just put it full screen so you can see what it does. We've got a bunch of dentists. So we've zoomed in on a fun part of the graph, I'm sure, for everybody. And there's a whole load of dentists from different places it looks like they're different places in the US. You notice there's two different categories. So we've got dentists and we've got general dentistry. For now, I'm going to switch back to the presentation again. So I can just, I'll just walk through. I think I've done this, kind of done this a bit in the browser, but we'll just walk through it on here as well. So as I said, this is removing properties, and this is we're using and in this bit we're using the unwind command to help connect our categories to the businesses. We can then do the same thing for users. So this is what the equivalent code looks like for creating the users part of the graph. So it's pretty similar to before, but rather than processing the business JSON, we're processing user JSON, and we're creating some nodes with the user label. And this time we actually have a friends graph. So there's a Yelp social network that we are putting into our Neo4j graph. And we can do a similar thing with reviews as well. So this is the equivalent code for reviews. So again, different JSON file. And now we're connecting businesses, users, and reviews together. It's a bit tedious running all these commands in the Neo4j browser because you can only run one at a time. And so what we might want to do is put them all together in a script. And we have a tool called the Cypher shell that is really helpful for allowing us to do this. And it's designed for, you can run it interactively, but it's also works very well for running multi-line Cypher scripts. And this is what it would look like. So we can create a file with all of those Cypher statements that we created before, and we can pipe it into this Cypher shell tool. Let me just show you how we would do that. So if I come back over to the Neo4j desktop, and I'll go back to my home screen, if I click on the Manage button, I get a few more options than I had before, and one of them is Terminal. And if I just scroll up, hopefully this is big enough for you to read it, but we're just catting a file, import apoc.cypher, and then piping it through to the Cypher shell tool. Only other thing I'm doing there, obviously you can see the password of my local Neo4j. You don't have to pass that in on the command line. You could it could prompt you for it, and then I'm saying I want it to give me some verbose output. By default, it has a different formatting, but for doing scripts that import data, it's useful to see what exactly is happening. And so you can see here we've created 500 nodes on the first statement. We've got another 58,000 on the second one, and then 88,000 on the third one. Let me just show you what this file looks like. So I'll just paste that down here. So this is what the file looks like. So a lot of it is similar to what you've seen already. So we create the businesses and categories, and then we've got the users and reviews. So it's exactly what we had on the slide, but we are just restricting it to 1,000 businesses, 1,000 users, and 50,000 reviews. Only other thing to notice is we are semicolon separating these statements. So that's how the Cypher shell knows that we've got another statement coming up. Okay, so that's cool. So we've now loaded in a decent subset of the data. But what can we do better? So the limitations of what we're doing at the moment are that it's all running single-threaded, and we've got to make sure that what we're importing, the transaction state that gets generated from that, can fit into the RAM of the machine. So I've got 16 gigabytes on this machine, on my laptop, for example. The transaction state is the state that gets created when you try to do a write query. So for example, if we did a query that was creating a node, there would be a command called that creates that node. If we then connect it to a relationship and set some properties, there would also be commands for that. And those are all pieces of data or pieces of state that live in memory for the duration of the transaction. And that works pretty well when you're just doing small transactions. There's not actually a lot of stuff to keep in memory there. But when we're doing big imports, we can, if we do it on a file that's too big, we can easily run out of memory on the machine. And so what we actually want to do is get some help and not do all of that in one big transaction, but maybe batch it up a bit. And there's a tool called APOC periodic iterate, which is very handy for these big data imports, often for when we're just starting out with a data set. And it does exactly what we need. So it splits up a transaction into batches and then optionally runs those batches in parallel. So let's have a look what that would look like. So here we're running the same JSON command in the middle for processing the business JSON file. But this time you can see we've split it up into two queries. So hopefully you can see there's a little comma here. On the first one, we say we need to feed it a stream of value. So what do you want me to process? And in this case, we're just giving it every one of those lines from the JSON file. And then in your second statement, you say, okay, what do you want me to do with it? And in this case, we're just saying, I want you to create business nodes if they don't exist and set a bunch of properties on it. You notice down here, we're indicating a batch size of 500, and we're saying that it can be parallel. So it's splitting up those streams of business pieces of JSON. It's doing 500 of those in batches of 500, and then it will try and parallelize the creation of them. When you're using the parallel true parameter, you've got to be careful that it can actually successfully parameterize this. If you've got queries where they might be touching the same part of the graph, then you're going to end up with failures and from deadlock detection exceptions. And so there's also another parameter called retries that you can use in that case. But a safer thing to do is try and work out, are there some bits that are really easily parallelizable? So for example, in here, I know that the businesses are all unique in that file, so I can parallelize that quite trivially. And so yeah, I didn't even realize I'd even helped us out. So that's just zooming in on the loading JSON, and then we're as I said, we can go and run a particular command over every line afterwards. So we've got a script showing how you would convert everything for that as well. So if I just quickly go back into our we've got iterate. There we go. Import APOC. So this is what it looks like if we process using APOC periodic iterate. It's pretty similar to before. I've just split some of the things up. Okay, so that's a good starting point. So that's completely programming language agnostic, and you can do all of that just using the Neo4j browser and the Cypher shell and your knowledge of Neo4j and Cypher. But we can actually probably do a bit better if we use the Neo4j drivers. So Neo4j, the company, has 4 official drivers. So we've got drivers for Java, .NET, JavaScript, and Python. But there are also community drivers for Ruby, Go, Swift, Elixir, and PHP. So there's almost certainly a driver for whichever language you're working in. For this session, we're going to keep the people who like Python very happy, and the others of you we'll have to just follow along. And hopefully, there's not too much complex code in here. But all the drivers are roughly follow the same structure. To install the Python Neo4j driver, we can use the pip libraries, which go pip install Neo4j driver. And now we can import the data directly from Python rather than having to go into the Neo4j browser. So on our first line, we're creating the driver. So all of the languages have something similar to this. So you say, I want to create the driver. You indicate to it where is Neo4j running, and then you can pass in your authentication details. If you were doing this in a real application, feed that in from an environment variable rather than hard coding it. I've just done that to save space on the slide. On our next line, we're then opening, we've got to do, so where apoc.load.json process the JSON file for us, we've got to do that ourselves now. So we say, I want to open the file, and then we need to create what we call a session. So a session is, so a driver lives for the duration of an application, and a session would be often on a user request response basis. And within a session, we can run multiple Cypher queries. And so you see in this one, we're iterating through the file. We're then loading the JSON for that file. So we've got a representation of the business, and then we're executing a Cypher query that creates the business and connects it to a category. If you want to look at this example in more detail, I've got the link for it down the bottom. So Angelica will send out the slides afterwards, and you can take a look at that if you haven't got a screenshot of the link. The problem with this version is that we're processing every single business in an individual transaction, so it's going to take a long time to do this. So what we might want to do instead is handle more businesses in one go. And so this piece of code here is an iteration on the previous one, where we're batching up the businesses into groups of 1,000. And so there's a syntax here where we can say, I want to begin a transaction. And then I can run a load of statements in it. And once I get to 1,000, then I'm going to commit it, and I'm going to start a new transaction. And so that works a bit better than the previous one. But it's still like there's a lot more code to do if we want to do this approach. So a nicer way than that, I think, is to make use of the unwind statement. So we'll still do our batching, but this time we'll just build a bunch of lists. So we're building the items list up here. And then when we get to 1,000, we'll call our Cypher statement, and we'll use the unwind statement to go through each of the items and again execute our merge business and connect it to categories piece of code. And what we're doing on the screen here in Python is effectively what the periodic iterate is doing. So it's taking, okay, you've given me some JSON. I'm gonna on every 1,000, I'm gonna run this statement for you, and it also uses the unwind as well. Okay, so that works okay, but it will take quite a long time to get the whole Yelp data set in because there's lots of stuff there. What we might want to do instead is use the Neo4j import tool to get the initial data set in, and then if there were some changes that we wanted to make to the data set afterwards, or if Yelp released some more data that we want to update our data set with, then we could use one of those previous tools to do that. So the Neo4j import tool, let's have a look at this. So this is a command line tool for bulk importing initial data sets from custom CSV files. So there's quite a lot in that sentence. Let's have a quick look. What does it mean? So first thing, command line tool. So this is available where I was running the bin Cypher shell. You have a bin Neo4j admin, and there are a bunch of commands on there, and one of them is the import. And I've got there's the capture of what will get printed if you just call that on its own on here. So you can see it's got, you can indicate which database you want to write to. You can say where it should read nodes and relationships from. And there are a few extra pieces of information down there as well. Now this tool is a bit different than the other ones. So with the apoc-load-json and with the Python driver versions of the import, we had Neo4j, the database was running, and we were executing it directly on there. With this tool, we're doing an offline import, and we'll go into what exactly that means. But first, this is really handy for doing initial dataset loads. And so yeah, so this is just diagram. It explains what we've been doing. So far with our previous two examples, we've got the raw data. In this case, it's JSON. We then move it through. When we execute a Cypher query, it will create an entry in the transaction log in Neo4j, and it will then write the entries of that transaction log into the store files. The advantage of that is that if something crashes, we have a way of recovering. And with the import tool, we don't have any of that safety. We don't have the goodness of Cypher anymore. So we're effectively going straight from the raw data over to the store files. So when you're running this, it's going to be faster because we've skipped out that whole transaction safety stage. But if your process crashes in the middle of creating these store files, you're going to have to start again. There's not the recovery mechanics are not there. The advantage is it's really quick. So before we look at how to use it, let's just have a look. What exactly are these custom CSV files that we need? So imagine that we want to create a graph, and we've just zoomed in on a particular part of it. So we've got a user, Bob, with ID 1234, and Bob wrote a review, and the review is ID 678. Text is awesome, stars is 3, and we want to know this is what the file format would look like for the Neo4j import tool. So if we go from the top, so we've got one file representing the users, we've got one file representing the reviews, and then we've got one file representing the relationships between them. On the top row, we've got what we call a header, and we're using a grouping there, and the groupings are pretty similar to label names. So here we're saying everything you see in this column, you can refer to it as being in the user group, and then if we come across to the middle one, this is the review. And the way they get used, the review and the user, is that when we come down to our relationships file, we have to indicate a start ID and an end ID. And we're just saying that the ID that you see in here is going to be unique inside this label, inside this group, rather. So 1, 2, 3, 4 here, refers to 1, 2, 3, 4 there, 6, 7, 8, 6, 7, 8, 1, 2, 3, 5, and so on. And then we've got some properties as well that will be created. So that's the file format that we need. So how do we get those files? So I've got a Python script that does it, but you could equally use any other programming language. There's no reason that you would have to use Python. And this is the code that generates the business CSV file. So I'll just zoom in a bit more detail. So one thing I like to do is keep the header files separate. So this is particularly useful if you're working with really big data sets. Often, I think the idea came around from what people were doing in Hadoop, where you often get part files. And the nice thing about splitting up the header is that if we make a mistake in it, we'd have to run the whole process again, or open up a massive CSV file and try to just change the first row, which can be quite painful. So I'm creating a separate header file, and it just contains the business ID, the name, the address, the city, and the state. And then we're going to write the business CSV file, and we're just going to put in, we're going to have a CSV file which has each of these items in. So we're just pulling out from the JSON, business ID, name, address, city, and state. Maybe we can have a quick look at what that looks like. So I'll just go back to my browser. So let's just check where we've, I'm trying to remember where I put it. I think I might have it over here. So if we just go here, so this repository is all online. So we'll just see if we can click on that. So if I copy the path to there, and we'll just go back into our browser, and let's just do, we'll get the first 10 things from that file. So that's what the business CSV file looks like. So you can see we've got a business ID, we've got a name, we've got an address, and then there's a header file there as well. So if we just paste that in, that's even simpler. So you can see it's just got one row, business name, address, city, and state. And if I just clear this screen so you can see everything that's in this folder, these are all the files that we're working with. So I've created, this is the structure. So you can see I've gone a bit further than what we're going to do in this talk, but we've got users rate reviews, we've got users are friends with users, we've got obviously the individual users, we've got reviews are reviewing a business, we've got, I've then got a bunch of extra stuff I've been doing around locations. So we've got businesses in a city, businesses in a area, businesses in a city, cities in an area, areas in a country. So I've just built a bit of an extra thing that we're not going to cover in here. But you can see this is what the CSV files look like, and I've got one big script that generates all of those. We'll just have a look at one other one in a bit more detail. This is the category, the code that generates the category CSV file and its header. It's pretty. I mean, all of this code is pretty similar. The only extra thing we have to do here is we have to build a set of unique. It should say categories actually rather than cities. I must have done some refactoring that's gone a bit wrong. So unique categories, because you'll see the same category come up in lots of businesses, and we don't want to put that into the CSV files multiple times. And then that just means that we just have to delay when we write the categories into the file. But yeah, you can do this in any programming language, and I expect it would be, if you could probably parallelize some of this and maybe do it more easily in some other programming languages that you're familiar with. Okay, so we've got our CSV files. How do we use the Neo4j import tool with our CSV files? This is an example. This is an example of creating the same graph that we created with the APOC load JSON and the Neo4j drivers code. This is what it looks like. So first thing is we've got to indicate that we are importing CSV files. There's also a mode for importing another database. So if we're trying to move a database from one place to another, we can use this tool to do that as well. But in this case, we're creating a new database. By default, it will create it under data databases graph.db. But you can override that name if you wanted to. If there is a database there already, it will fail straight away and say, you've already got a database, I'm not going to create it. So keep that in mind. This is a tool for creating a brand new database, but it will not trample over stuff that's already there. So we've got our mode CSV. Next, we need to indicate where should I read nodes from. So you can see on the right-hand side of this line, we're saying we've got a business header, we've got a business CSV. The colon business on the left-hand side of the line is indicating that I want every node in that file to have the business label. So remember, we want to label all of our business nodes with that label. That's what we're doing there. And then we do the same for categories, and then for relationships, we've got pretty much the same thing. We just point it at the relationships file, and we're saying this time I want the relationship type for all of the connections in this file to be in_category. And then the last interesting thing, so the other bits of this code are just repeating the previous sections. We're saying if you find a missing node, it's okay to ignore it. So by default, if in one of these files there's a node, there's an identifier that isn't in the relationship file, that isn't in the node, a corresponding node file, it will it will fail. Here we're saying it's okay, just report it back to me at the end. And we're indicating that some of our fields have multiple lines. So for example, the review text field, reviews often have line breaks in them, and so those can go over multiple lines. If we run this over the whole data set, I just took a print screen because I figured we probably don't want to wait 11 minutes for this to run, but you can import the whole of that Yelp data set in 11 minutes, and then you'll have a database ready to go. So I'm just going to finish up to show you a couple of queries that we might want to run on this. So here's an example of finding businesses with the best reviews. So you can see there are some businesses that have been reviewed 5 by everyone. So probably this is we want to make this review maybe limit only show businesses that had been reviewed more than 5 times, perhaps, or some higher number. Either that, or these businesses are just amazing and everybody loves them. I noticed, like completely by accident, there's a Needham law firm down in the third last position. I don't think that is a relation to me. And then another query we could do would be, can we find similar categories? So imagine we like businesses under the dinner theatre category, and we want to know what other similar categories are there. One way of working out that similarity is to have a look at what businesses, what other categories businesses that are dinner theatres are also coming under. And so in this case, not to any great surprise, I imagine restaurants and nightlife also show up. Okay, so that is the end. So I'm going to hand back to Angelica in case we have some questions.
Yeah, definitely. Thank you so much, Mark. That was great. Just a reminder to everybody, if you do have some questions for Mark, please just enter them in your questions box in your GoToWebinar control panel. And we'll start it off with a couple here. So does the Neo4j driver for Python require paid subscription?
No, all the drivers are available. You can just get them. You can just install them. If you wanted to run that on Neo4j Enterprise, then you would obviously have to follow the guidelines for licensing around using that version. But the drivers work with the community version and with the enterprise version.
Okay, great. And how can we export the node and relation to JSON?
I think there might be a procedure in APOC that would allow you to do that, but you'd have to check. There are a lot of functions. If you search for Neo4j APOC procedures, there's a list of all of them. So if you search for export, you can check whether or not that exists. It may well do.
Okay. Can I use the import tool to load additional large data sets somehow? So
at the moment, the tool is only for doing initial data sets. But yeah, people do often ask, can I use it to add extra things? And so we do have a project that is internally working on how we can do that, but it's not released yet. But so you'll have to watch this space for now.
Great. And in your example, you were using a CSV to do your import. Is there a reason for using a CSV versus an XLS?
So the reason I was using CSV files is because the Neo4j import tool relies on CSV files. If you had a spreadsheet and you exported it to CSV, that would be effectively equivalent in some respects. But obviously that tool has no idea how to read macros that might be in a spreadsheet, for example, and it also has no idea how to read if you had multiple sheets inside a spreadsheet. So that's why the simpler CSV format. You can actually also get that the tool underlying that. There is obviously a Java program running, and so you could just run that against any data source if you didn't want to convert your data to CSV. But that's a bit more complicated piece of work than just running this tool from the command line.
Makes sense. And there are a couple of questions here around working from an RDBMS and moving it to Neo4j. So is there a library or a way to import data already modeled and stored in an RDBMS and move it into Neo4j?
Yeah, so there's a few different ways that you can do that depending on what tools you're comfortable with. If you like doing stuff in APOC, there's an APOC load JDBC, and so you can pass in a JDBC connection string and load data in like that. That works pretty well if you're just prototyping something and you want to quickly see how does this work in a graph. If you want to do an offline RDBMS to Neo4j import, then there's a tool called the Neo4j import tool. We can share a link for that afterwards, so you can either run that as a command line tool, or there's a way of getting it inside the Neo4j desktop as well. Angelica will send out a link which has all the instructions for how to do that. My colleague Pravina did a webinar on this about a month ago as well, so maybe we can also point you towards that one.
Yeah, definitely. And can you use Spark for bulk load instead?
So I'm assuming you mean, can you write those files, because effectively we're writing store files using that tool, so you want to use Spark to do that bulk load. I think someone did try doing that at some point, and I don't know that it's actually faster than this tool. So this tool, if you run it, I mean, I'm just running it on my laptop. It took 11 minutes on there. It will use all the cores of any machine you have. So I would suggest trying it out on a big machine first, to get like a big Amazon instance and try and import your data on there, because it does do like multi-billion graphs in a couple of hours. If you can, but sure, yeah, you would have to check out how exactly the code works, because it's doing some quite clever stuff to build the store files as quick as it can, and I don't know if it would translate directly to stuff you could parallelize in Spark.
Okay. And do you have any recommendations for handling data partition by date? For example, if you were to load entirely disconnected daily snapshots on a day-to-day basis?
So for that, I'm assuming that what you mean is that you don't want any of that data from today to be able to query stuff from yesterday. If you were doing that, probably the easiest way is to just create completely separate Neo4j databases. One feature, I guess, we'll get at some point, but which will make that a bit easier, is being able to handle multiple graphs on one Neo4j service, so that you could name a graph like today is my, I don't even know what the date is. Today is my 14th of March graph, and then I have a different graph called 15th of March. And there's some work around that in the CAPS project. So this is Open Cypher on Spark. So they're doing some of the work around there, and eventually that multi-graph concept will make its way back in, and I think that would be the best thing for your use case.
Okay. And if you're running Neo4j, how can multiple people be working on the same project in the same instance?
So, I mean, for that one, it's going to be similar to how it is for any other database project. What I've seen typically is there doesn't, I mean, with relational database projects that I've worked on, we often had a DBA that you had to route all your database related queries through. I haven't seen that so much on Neo4j projects, but there is often one person who's very knowledgeable about it. But yeah, I mean, you could use it with multiple people working on the same project, the same as you could use any other tool with multiple people working on it.
Okay, great. And is there a way to export the output of the graph from Neo4j into a UI for users who are less tech savvy?
So the visualizations that we had on the screen can be downloaded as a SVG or PNG and used somewhere else. But yeah, that's all there. That's all there is there for the moment.
Okay. And do you have any recommendations for those who are just getting started with graph modeling? Maybe some different links or articles?
I would suggest the best. There's lots of examples of this in the graph databases book, so graphdatabases.com. If you have a look at there, that book goes through lots of different graph modeling examples. If you want something in person, depending where you're located, we run every quarter. We do a graph modeling session in London, and I think in several of our other European cities as well, where we actually take a data set and take an example problem domain, and people try and work out how they would model it, obviously with the help of an instructor in the room as well.
Okay, and I think we have time just for a couple more. So in the case of multiple users that you were describing before, How can we manage the permissions? Is there a view in Neo4j essentially?
No, there's no materialized view concept at the moment. And you can, if you look up Neo4j user roles, there are different roles that people can have, but they're currently not. It's not a first-class thing to control access to different parts of the data. You can only control access to a database itself. So, for example, you can set people to have an architect role or a reader role or a writer role, and they have different permissions that they have. I think that might also answer another question that we've got. In case of multiple users, how can we manage permissions? So if you search for Neo4j user roles, there's a whole section of the I think it's the operational guide explaining what you can do at the moment. And there will certainly be more features added around that because it's a very commonly asked for thing.
Okay, and what is the easiest way to create multiple databases algorithmically? For example, if you were to use a Python driver.
So if you want, so for multiple databases, you would have to have multiple Neo4j servers, and so that, for example, they would be running on different ports. So the default port, for example, where Bolt runs is 7687, so you could run some other Neo4j instances on a different port. But again, I think there's going to be more features in the 3.4 and 3.5 series that make this easier than it is at the moment.
Okay, and just one more here. So while modeling, do you have any recommendations on the direction of the relationships? Any recommendation essentially to have a flow in your model?
Not really. I mean, the example I showed is all the advice I have for that. So I guess if we could just recap quickly what we mentioned. So I was suggesting try and keep the verbs active, so the go rather than passive. So we had user wrote a review. I would name it like that rather than say the review was written by a user. But that's just a personal preference of naming things, and you'll tend to see the examples are all written like that. But there's no particular reason that it has to be like that. It's just a stylistic thing.
Okay, and lastly, is there a good strategy to bulk load if you don't know the structure of the data ahead of time, such that modeling is tricky at just discounting the bulk load?
No, if you're doing iterative building of the model, Cypher is the best tool for that. As you observed, the import tool assumes that you know exactly what your structure is before you build it, and that's how it's able to run so much more quickly.